Welcome to Brain Vision.
So let's calculate how much ice is melted when a sample which is actually cooled in an ice bath. All right. Now we are told that the mass of sample, let's say M subscript S, is actually 16 grams. It's 16 grams. Now the specific heat capacity, let's say C subscript S, is giving us 2250 joules per kilogram per Kelvin. All right. And then the temperature of the sample, the initial temperature of the sample is 19.5 degrees Celsius. And then we are cooling it all the way down to the temperature of the ice, okay? To the temperature down, all the way down. Okay, all right. Now let's look at the mass of the glass vial. The mass of the glass vial, let's say M subscript G, M subscript G for the glass is 6 grams. And then the specific heat capacity of the glass vial is 2800 joules per kilogram per Kelvin. All right. Now, in this mixture or in this system of substances, we can say that the mass or the heat energy from the glass plus the sample is equal to the latent heat of fusion, which causes the ice to melt. So the heat gained by, the heat lost by the glass is given as MC delta T, okay, plus the heat lost by the sample, MC delta T. Let me differentiate that. So this is for the sample, and then this one is for the glass. Okay, it's equal to the latent heat of fusion of the ice, okay, times the mass. All right, okay. So you need to know that we are losing heat from these samples into causing this ice to melt, All right. Now, let's move on. Now we have the mass of the glass to be 6 grams, and 6 grams when you convert to kilograms, that should give you about 0.06 kilograms. So I've converted straight away. You can sit down and go through how to convert to kilograms, from grams to kilograms. So 0.006 times the specific heat capacity of the glass, which is 2800. All right. And then the temperature change. Okay. We are cooling all the whole system to a final temperature of 0 degrees Celsius because that's the temperature of ice at that point. Okay. The temperature of ice at that point. So we have 0 minus 19.5. 0 minus, let me rewrite that. 0 minus 19.5. Good. Plus the mass of the sample, which is 0.016 multiplied by specific heat capacity of 2250. That's for the sample, into bracket, the same temperature, 0 minus 19.5. Okay. 0 minus 19.5. All of this is equal to this. It's equal to this, which is the mass into bracket 33400, where this 33400 is the latent heat of fusion of the ice. And remember, we are calculating the mass of the ice that melted. All right. Okay. So when we go through this, now since heat is lost from the system, that is, heat is lost from the glass vial and the sample to the ice, heat is lost. Okay. All right. So we're going to have negative 327.6 minus 7 0.02, which is equal to the mass of the melted ice times its value 334,000. All right. So now when we do this, we have negative 1029.6 is equal to m to bracket 334,000. All right. So when we make m the subject, we're going to have 0. When we make m the subject and divide 102 and divide 1029.6 all by 334,000. All right. Now this is going to give us 0.00308 kilograms. And then, of course, if you convert to grams, that would be about 3.08 grams. 3.08 grams. Let me rewrite that. 3.08 grams. So this is the amount or sample of, or the mass of the ice that melted in that mixture. Now, remember, we don't have a negative value for mass, so we ignore the negative value in here. If not, we could have added it here, or we just chose to ignore it because it doesn't really affect the mass that much. It just gives us an information that